Hello, welcome to the Continuous Integration Continuous Development tutorial. This part is going to be about the introduction, introducing you to what exactly CI/CD is and what it generally means to you. What you see on my screen is a terminal indeed, but we're not going to be using that for this section. But I leave this in a split screen for consistency among all my videos. On the left side in the browser, which I'm scrolling through right now, is the tutorial page from the awesome work bootcamp that we hosted in February is certain. So we're going to go ahead to the introduction part. And the goal of the introduction is to explain what CI/CD is, and you'll be able to understand by the end of this video all the different resources to explore this more in depth to your own liking. Note that we don't particularly require that you use a particular solution. However, we will generally encourage GitLab for all the CI/CD work that we're doing in this tutorial. But there are other solutions which I will mention towards the end of this video. So CI/CD itself is broken up into two pieces. The CI part is the continuous integration part, and that is the literal continuous integration of code changes that you make. Those code changes could be, for example, analysis code or code that you use for plotting in your offline analysis, maybe doing a statistical fit or doing some histogramming. It could be, for example, LaTeX code that you're using to write up a document and you want to make sure that the document still compiles or that you're not missing anything. It could be, for example, that you're building a website using HTML, CSS, and JavaScript or some other language such as Node or Ruby and so on, and you want to make sure that the website still builds in a way that you can deploy. Which leads to the second part, the CD part, the continuous deployment. And continuous deployment is about the literal continuous deployment of code changes. The idea is that as long as the CI passes, that you've done all the tests and checks that look great, then you can go ahead and deploy all of those changes live. Deploying is a general phrase where it can mean, for example, if you have analysis code and you pass all of your checks, such as your flow checks and your physics checks and so on, then you can go ahead and deploy it by sending it to the grid or some batch computing to process over a larger data set for you automatically. Similarly, if you are writing a document, you can imagine deployment being compiling a PDF and uploading it somewhere automatically for you to view, and so on. There are lots of different ways and different contexts in which CI/CD works, and if you have questions about it, feel free to ask me or any of the mentors. Now, at the end of the day, you can imagine this being sort of like a catch and release, almost like fishing, which is why I have a GIF here about it. And the idea here is that you want to be able to catch exceptions, but if there are no exceptions to catch, then you can go ahead and release the code in the wild, which is a little bit different than fishing in a way. So, imagine that the CI needs to be able to catch these break-in changes, but this is a little bit tricky because you can imagine that perhaps your first instinct is to parse the log file and look for errors or warnings. But how do you know that every tool that you use is going to be outputting errors or warnings in the same way? How do you even know that the tool you're using is going to print out an error or warning in the first place? There has to be a mechanism in place for the CI job in order to catch these changes that break. Similarly, let's say that you want to be able to check it with some other code like, C++ versus LaTeX versus Python. There has to be a way to do it consistently. We'll talk about that in the next session. At the end of the day, the whole idea is to automate your entire workflow. Anything that you can run on your computer can be equivalently run in the CI job. There could be a little bit of extra work that needs to do to make this happen, to make it more CI friendly, but it's definitely worth it because it pays off in the long run by saving you time and having to rerun all of these checks all the time by making your computer do it. So, as I mentioned before, CI/CD isn't just for analysis code, but it can be for anything that you can think of. Anything that you want to be able to automate. Let's say you're a convener or sub-convener, or you're chairing some group, and you need to maintain some documentation about the group, such as the status of meetings, or links to various things, you can imagine that you can build up a repository that stores data about all this information and automatically update a page whenever you have new changes to make. You can imagine it this way, you can version control pretty much everything you like. And there are lots of different solutions as I mentioned at the beginning of this video. We will generally encourage that we use the native GitLab CI/CD solution, which is built into GitLab in general. Now, there are other solutions, such as, for example, if you are using GitHub. And then there's Travis, Circle, all the way down to CodeFresh. And I made this list in order of the CI/CD environments that I like the most to CI/CD environments that I like the least. So, for example, if you are using CodeFresh, please don't. I'm not going to help you debug that. So again, for today's lesson, we will only be focusing on GitLab solution. However, all the concepts that will be taught today, such as pipelines, stages, jobs, artifacts, dependencies, caching, they all exist in some way or form across all of these different solutions, perhaps by the same name or different names. So, for example, GitLab has two features known as caching and artifact. Travis doesn't quite have the same functionality in place. However, they do have similar names, but you should be aware when you're translating from one CI solution to another, you should be aware of the differences amongst the two functionally. And again, if you have any questions about some of the more popular ones, feel free to ask me or any of your mentors. I'm sure we will be able to answer your question in some way or form. So let's go ahead to the next section and we will start understanding about breaking changes.